So today we will start our, I would say, a very, very important topic in deep learning. This is, I can say, is the core of the domain of deep learning, right? So please try to understand the topic in a much more clear manner. And at any point of time, if you're facing any trouble, just do let me know, okay? So today we will discuss about the architecture named as CNN. What is the full form of CNN? The full form is Convolutional Neural Network. Till so far, we have discussed about what is neural network, how can we create a neural network, right? With its implementation, we have covered up, in our last discussion, from scratch, how can we create a neural network? Today, we will talk about the convolutional neural network, CNN. You will find a lot of architectures in deep learning whose base is this CNN. So whatever discussion, whatever concepts we will learn today, it's applicable to all the different you will see widely famous architectures. The base is CNN only. The research papers which you will be able to see after this session, maybe in the upcoming class, I will also showcase you. You will see that whatever concepts we are learning today, the same concepts are applicable to all those specific bigger architectures of deep learning as well, which nowadays are having a lot of practical applications. So let's get started and we'll try to understand that how is the CNN architecture will work, in which specific use case these architectures are very widely used. And our main focus for today is to understand the, first of all, internal working of CNN. Internal working meaning we need to understand the mathematics behind how CNN works. Once you understand this part, the very first portion of today's class will be on this specific focus. Once we get the understanding of its internal working, its mathematics, then in the second part of our today's discussion, we will focus on implementation. So whatever we have learned in the above portion as a understanding, we will try to do the implementation for the same. And if we will be able to accomplish both of these tasks today, it will be of great deal, right? So that's the whole objective. So are you guys ready? Shall we start our discussion? Now, usually, I hope you all remember in the last class, I told you that we will be working in the upcoming class on MNIST data. Do you remember that? And I told you MNIST data is a open source data which contains the images of numbers. Images of numbers. Now you all know when I'm saying numbers, numbers belongs from 0 to 9. So somehow this specific MNIST data, which is the open source data, contains the image of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And at the end of the day, we need to create a model, a deep learning model, which will be able to classify that whether this image belongs to 0 or 1 or 2 or 3 till 9. So somehow today we are dealing with something called as multi-class classification task. Do you guys agree with me? We are dealing with multi-class classification task. Why multi-class I am saying? Because we do have more than two classes. So it's not a binary class, it's a multi-class. I think in the last discussion when we did the implementation, as far as I remember, just let me know if I'm wrong, we did binary classification task. At the end, I think we have applied a sigmoid layer. Today, at the end of the architecture, we will apply the softmax layer, right? Architecture means description of layers. Architecture means the complete full-fledged neural network. Layers are one by one input layer, hidden layer. If you have two hidden layers, then output layer. when you combine all of these layers, right? Input, hidden, let's say 2, and the output. So the complete neural network which you get is what we say as architecture. That is the meaning of architecture. Okay. Layer is different story. Layer, to I think in the very first class we have discussed. This is input layer. This is a layer. Layer is a single layer. Output layer. Every layer has its own purpose. Hidden layer. But when you combine all these layers to perform any significant task, that combining together is what we call as a architecture, neural network architecture, right? Now, let's try to understand today. If let's say I will be having, I have captured the image of MNIST data, and we will try to understand that how this specific CNN will work, how this convolutional neural network will work to detect the image, maybe to classify that this image belongs to 9, right? First of all, as I told you in the previous session as well, whenever you are dealing with image-based data, internally, when we see image, for our eyes, it's an image, but for our model, that image is nothing but is a pixel value stored in a matrix, matrices form or in a multidimensional array form, right? So if I will say that this specific image, which you can see on the, I would say, left end screen, is what we called as a input image. And this is actually an input image of 9. Now, how I will get to know that it is 9? Because if you will see this image very carefully, wherever you can see -1, -1, -1, it means that there is no as such important image available over there. And wherever there is a 1, try to combine all of this. Wherever there is a 1, try to combine this architecture. This, this. So can you see that wherever 1 is there, I have just tried to combine this. So somehow I got one square, then a straight line, then one diagonal line, something like this. One square, then one straight line, then one diagonal line. Now, if my model will be able to diagnose, or like will be able to capture will be able to capture these three things, the square thing, the straight line, and the diagonal line, then will that model will be able to help me to understand that this image belongs to 9? Can we say that this is 9? Internally, this is not 0, this is not 1, this is not 2, this is not 3, 4, 5, 6, 7, 8, 9. The only possibility is this is 9. Now, one thing I think now you will be able to understand. So wherever this lines are there, this important images are there, that will be represented with 1. And in the remaining portion, it will be represented by -1. Is this part is clear to everyone? And remaining values, whatever be the input shape we will be having, that will be -1, -1. Matrix size is always same or it will be different. In this specific data set, it is already provided as 28 cross 28. which will be same for each and every image. But it might be the case that when you're working with other specific data sets, the images are of different size. So always remember, whenever you are working with any project, your first task is to carefully check that whether the size of all the images, all the images in a given data set, in a given data set is same or not. And if, let's suppose, the size is not same, then, so there are two options. Either the size will be same, then you can work further. There is not an issue. If the size of each and every image available in your training set is different, in that case, you need to first of all make sure that you will fix one size of all the images that you will be having. You will take one standard size, right? And you always have to make sure that before feeding your image into a model, all the images will belong to a same size. You will have to do a standardization on top of that. But in our case today, which data which we are working with, this is already of same size, so that is not an issue for us, right? How model understand when to start joining the points? This joining the points by the line is what I have done for you. Model will do it in some other manner. That is what we will discuss today, how model will be able to detect that this belongs to 9. This specific detection part, which I have done, it's not for a model, it's for you guys to understand that this is 9. This is for you guys, not for model. Model will apply maths internally to detect that it is 9, which we have not covered up, which we will cover up in today's class. But first of all, you guys have to understand that this is 9. That's why I have tried to merge the lines and showcase you that why I am saying that this is 9. Is this clear? Shall we move ahead now? Everyone is okay till so far? Yes. Now, the next question is how my model will be able to understand and detect that this specific image, this specific input image belongs to 9, and will be able to give me the answer or the probability of 9 to be very, very high, right? That's what the concept of softmax says, that it will try to provide the probabilities from 0 to 9. And if our model is correct, it means that indirectly it will showcase to me that the probability of having this input image belongs to 9 should be very, very high as comparable to other images. Now, how, with the help of this CNN based architecture, it will be able to detect that this is, specifically 9. This is where our network usually uses the concept of what we called as filters. Now, this discussion I am saying is for the convolutional neural network. Now, this is not for us. As a human being, we can recognize it because we have already fed it in our head what is 0, what is 1, what is 2, what is 3, and so on. But for our model, they don't understand all these things. So what we have to do, we will have to apply filters, which we called as kernels as well. This is one of the same thing. Now, these filters' purpose is to detect and extract the features which belongs to 9. So this kernel specifically detect that what are the edges, what are the specialties that this input image holds. With respect to every edge, with respect to every corner, which it will try to detect, there will be a separate filter which will be used. For example, this is one of the filter called 3x3 filter, which you can see. Now, in this specific filter, in this 3x3 filter, a maths will be applied, where this complete filter will be put over here in the very first cell of 3x3. And how the maths will be applied? This -1 will be multiplied with this 1. Then this one will be multiplied with this one. Then this one will be multiplied with this one. In this way, every specific number in the input image will be multiplied with the kernel value and a complete addition will be done. So if you will be able to observe what will happen, minus 1 into 1 plus 1 into 1 plus 1 into 1 plus again minus 1 into 1 plus 1 into minus 1 plus minus 1 into 1 plus minus 1 into 1 plus 1 into 1 plus 1 into 1. So anyone who can just let me know what is the answer of this specific part? Minus 1 plus 1, I think they will get cancelled out. 1 minus 1, they will get cancelled out. Minus 1 minus 1 is minus 2, minus 3, and plus 2. Is this we are getting as minus 1? No, this negative of 0.11 is a normalized value. I will let you know how we are getting that. Is this minus 1? After doing a calculation, just let me know. Then maybe we can move ahead. If you can see, minus 1 divided by 9 is negative of 0.11, which you can see is the specific value. So now what will happen is, whatever value you are getting, for example, here it is minus 1, this value will be normalized. How it will be normalized? Whatever value you are getting, minus 1, divided by the count of this filter values. 3 cross 3 is the filter size. 3 into 3, 9. How many number of values you have in the filter? 9. Minus 1 divided by 9, minus of 0.11. So in this way, you will get the very first value, which is 0.11. Again, I am repeating, it's quite simple how we are multiplying. So please pay very close attention today what we are discussing over here. Otherwise, you will skip the entire session. So focus is something which is required. This complete specific 3 cross 3 filter, which is 1, 1, 1, 1 minus 1, 1, 1, 1, 1. This whole filter will be put over here in this 3 cross 3 matrix in the input image. Now, what will happen is, every specific value, wherever it is placed, what is the position of this in the filter? 1. It will be multiplied. Then you will put addition symbol. Then again, do the same task. 1 into 1, plus 1 into 1, plus minus 1 into 1, plus 1 into minus 1, plus minus 1 into 1, plus minus 1 into 1, plus 1 into 1, plus 1 into 1. So whatever value you will get, which is minus 1, that is the answer. Now you will normalize this value with the total number of filter values that you will be having, which is 9 in this specific case. So minus 1 by 9, which is 0.11. Is this clear? Is this process is clear to everyone? I'm again repeating my point. Any doubt? Yes, it's element wise. Check the position of the element available in the input image and the filter. Same position, you have to multiply and put plus symbol in between. That's it. How we are getting this filter matrix? With respect to whatever be the detection you want to perform, whatever features you want to extract, you will be able to have by default multiple filters available, which you can refer over the documentation. That if, let's say, I want to detect any specific eyes, I want to detect any specific hands of a person. So for that, every specific filter is already defined in deep learning. You just have to apply a filter which is basically used to extract that specific detect object. So this filter is being used to detect the object, and the filters are the fixed numbers which are already defined to us. We directly have to use them to apply in our input image to get the answer. Is this filter same for all the models? It's not same. Again, I'm repeating my point. What specific thing you want to detect, accordingly your filter might get changed. This is a fixed value which we don't, as a user, as a developer, needs to remember. Everything is already predefined in the code. As soon as you will write 3 cross 3, automatically this specific matrix will be already defined in a model, in a CNN model, and it will be able to perform this specific task. So you don't need to cram it. It's just that you should know how actually it will be able to detect the feature part. That's the whole idea. Shall we move ahead? Now what will happen? How this next number 1 is coming up? Can you just do the maths? Step by step, now you have to move your path to one next step. Now this is the next matrix you have. 3 cross 3. Apply the same maths. 1 into 1. Apply the same maths. You will do 1 into 1 plus 1 into 1 plus 1 into 1. I think we will be able to get 3 plus 1 into 1 plus minus 1 into minus 1 plus 1 into 1. We will be able to get 3. 1 into 1, 1 into 1, 1 into 1. We will be able to get 3. Combine together 9. If you normalize this value, 9 by 9, which is equal to 1. That's why 1 we are getting over here. Is this clear to everyone? Now it is clear. In this way, our input image matrix will be shifted towards 1, 1 part, and matrix multiplication will be done with respect to the input image value and the filter part. And this is how we will be able to generate this entire output matrix. Yes, every time we will do the computation till we reach to the end. Then again, it will do for this specific matrix. Then it will do for this specific matrix. Then it will do for this specific matrix. Same step will be repeated for this specific matrix, then this one, then this one. And that is how you will be able to get the entire values. Just confirm to me, is this clear till so far before we will proceed ahead? Is normalization we divide by 9 because the filter having 9 pixels? That's correct. Because filter is having 9 values, that's the main reason we are dividing the values by 9. Why we don't take input size for filter matrix as well? Input size is always bigger quantity. Your kernels will always be a smaller quantity, right? So filter will always be a smaller dimension because it will try to detect with respect to individual input values that we will be having, what is the final outcome. That's why we will always take filter on top of the input image and the computation will be done accordingly. Is it fine? Shall we move ahead? Now, the important thing is, wherever in the output you're getting 1, wherever in the output you're getting 1, it means that this is the feature detection part which our model has done. Means this is where somehow our 9 picture will be captured. Maybe this belongs to one of the edge where the 9 is available. Maybe it will be able to capture this square box entirely. That this is an indication that one of the signal, one of the, edge is available at the spot of 9. Now, similarly, to detect this straight line, to detect this diagonal value, we do have different filters. Now, I will showcase you one bigger picture and then you will get a better clarity of what I am saying over here. Check this. So the very first filter which we have discussed is a loopy pattern detector, where it will try to detect that loop available in my 9, which, what is the meaning of a loop? That loop is this, which doesn't have any ending point, right? It is a rotation. 9 is just a rotation, right? So this is a filter for that, and it will be able to capture this one over here. Few minutes back, we have seen how it will be able to capture one. Similarly, as I told you, with respect to each and every feature detection part, each and every different sort of image you will be having in a given picture, you will be having a separate filter for that. For example, if you remember, the second component was that vertical line. For that, we have this vertical line detector. And if you will apply the similar kind of concept of multiplication and then doing the addition part, you will get 1 over here. And when you apply the diagonal line detector, which is this specific line, right? This specific kernel you will apply, you will get 1 over here. So in this way, you will get 3 ones, which indicates that the very first one indicates the specific loopy pattern. Second one indicates this vertical line. Third one indicates a diagonal line. And in this way, the features will be captured in a convolutional neural network. This is a kind of a feature map. This is what we called as feature map, which we are creating via this. Now, just to explain you this concept further, if you will be able to see, for example, if I want to detect 8, now, when we're talking about 8 contains 2 loops. Do you guys agree with me? 8 contains 2 loops, 2 never-ending portion. 9 contains single one. So we have applied this specific detector, and only one was one was visible to us, right? Because it contains 2, that's why here you can see 2 ones are visible to us when we apply the same filter. Why we have applied the same filter over here? Because this specific filter is responsible for loopy pattern detection only. So whenever you will see that in my I would say numbers, there is kind of a loop coming up, I will always go with this specific kernel. If this specific kernel will bring 1 at any point of time, it might be the case that it won't bring 1 at any point of time. It means that there is no loopy pattern. If 1 is coming up, it indicates that this is where the loop is going on in your image. And if 2 times are coming up, it means that somehow 2 times in your image, the loops are there. Are you getting my point, what I'm trying to convey over here? Let me share with you one more image to get more comfortable with what I'm saying over here. So if you will check this specific image. For example, this is the image, right? Here, let's say we want to detect the eye, right? This is the eye, this 2 eyes, I hope you can see. So we will apply corresponding to that eye detector, right? How we will apply that? How we will get to know that this specific kernel of 3 cross 3 belongs to eye detector? Above one belongs to loopy pattern, above one belongs to vertical line, above one belongs to diagonal line. For now, don't take a stress for that part. Already internally in Python, for every detector, the matrix is predefined. That's the beauty about Python programming language. We just have to call the kernels and automatically this kind of metrics will be there. Even as uh, user or developer, I also don't need to remember that. I just have to use those kernels and automatically internally this process will be done. Already the developers define the specific kernels numbers to detect the specific image. So once you will apply this eye detector, it will be able to showcase you 2 ones, which indicates that this is the position where the eyes are available. If you can see in the image and try to see once, you will be able to correlate this point. And that is how the features are extracted in convolutional neural network. That is how the features are extracted in the convolutional neural network. Is this clear to everyone? Filters are usually 3 cross 3 only. This is the standard size which everyone is using in almost all the available datasets that we will be having. Suppose I want to detect something new like nails, then it is yes. With respect to whatever thing you want to detect, nails, hands, foot, thighs, stomach, every body part, you can detect it. Detector is there, filter is there. It will scan the entire image, apply the filter corresponding to that, and will give you one on that specific position where that specific location which you want to detect is available. That's the whole point. Is this clear to everyone? What is the maths behind these filters? I hope this filter is not a new concept. When you, you know, how do you make a tea, right? Whenever you create, you will make a tea, you will have to use that chani to filter the chai patti, right, from that tea part, right? Similarly, with respect to each and everything that we are doing, for example, our complete body, we want to scan something, we want to check, for example, MRI, X-ray, you will see that in that specific space how internally these machines are working, will be able to give us those X-rays, MRI scans. Everywhere, somehow internally it is able to scan the things by this filtration process, which is basically able to detect that this is this specific area, this is this specific area, this specific portion. So this is not something which is a new concept. The only point is that when we will be having a huge amount of data, when we will be having a huge bigger size of image, that is where I hope you can now clearly able to understand that it will become a computationally expensive task somehow, because internally if the metric size is quite big, at that point of time it will do that many number of computations to get that specific value. That's the whole point which I want to convey over here, right? Is this possible that two filter for different purpose will give one at same place? No. For every specific position, we will be having a different filters available to detect something out of it. That is how detection will be done. Yes, exactly, Shivam. Is this okay till so far before we will proceed ahead? Is the maths behind the filters and how it works and give us the uh, exact feature part, will it be clear to everyone before we will proceed ahead? How the filter is being selected, there is internally, how many of you know the concept of hash map data structure? Mapping is being done. With respect to every specific detector part, there is a mapped value corresponding to that with respect to the kernel part. So whatever be the thing you want to detect, that specific kernel is being used to give you that specific result of extracting that specific portion. That's the whole idea. Yes, mapping to the relevant function. Key is the thing which you want to detect. That will be a unique value. As I told you, with respect to every unique area, there will be a unique filter. So key is the area which you want to detect. For example, eye. For example, leg. That is a key. Value is its filter value. Is it clear? Now, this is fine. But usually, when we try to curate this specific part, and when we try to shift one metrics at a time, right? I told you that initially it is at this specific position, then it shifts to one position. Then again, it further shifts to the next position. Few minutes back, I told you, right? I hope you all remember that. So this is what we called as stride. This is what we called as in a algorithmic term, stride. By default, this value of stride is 1. Stride means that how many positions you are moving ahead. But if you want to do faster computation, where you don't want to extract in depth all the features, maybe you just want to see the boundary of that specific feature, then you can increase this stride value as 2, 3, and so on. What is the meaning of 2? It means in that case, you are jumping 2 steps at a time. Maybe directly you're shifting from the first matrix to the third one. Are you getting my point? This is the meaning of stride. Stride means how many jumps you want to do with respect to one to second to third matrix in the input image. And accordingly, computations will be done. Accordingly, the feature extraction will be done. Stride is clear. Filter operation is clear. Shivam, it's not clear. It means if you're asking this question. Again, I'm repeating my point. What is stride? We will be having this 3 cross 3 filter. We know that this 3 cross 3 filter will be mapped to this input image. Calculation will be done. We have checked how it will be done. Once it is done, what I told you, that it will shift to next matrix. This is the next matrix. In this case, if it is shifting to next upcoming consecutive matrix, means the stride value is 1. Because here the jump is just one next matrix. If you are saying the stride is 2, it means that in that case, you're skipping the initial 2 columns and then you're shifting to the third matrix directly. So somehow what you have skipped is this specific matrix. Is this clear now? Filter size and stride size not at all interconnected to each other. These two are different concepts. Filter is a different story, which is 3 cross 3 filter is available, which we have to map on the input size. Stride means in the input image, how many jumps you want to do to capture the feature part. By default, you are doing one by one mapping of filters. If you are doing 2, it means 2 jumps you will do to get the next input image. That's it. Stride is a variable. It's not a matrix. Either the value is 1, 2, 3, 4, and so on. It's just a variable. The name is stride. If in algorithm you will find this term, you should know what is the meaning of that. Is it clear? Who decides? We will decide. If you want to capture detailing of every feature, go with 1. If you just want to see the overview of any feature, go with 2 and 3 and so on. Right? Optimum is obviously 1 because you will get the detailing of each and everything. But if you will do stride value as 2, the computation will be less, training will be faster. And if you just want to see a brief context of outside view of how your feature, how your input image will look like, then that will also work. It all depends on which specific project, what specific business use case problem you are working with. And depending upon that, you have to think about the values of all of these things. Shall we move further? Now, the next important concept is what I'm talking about, the concept of pooling. But before that, usually with respect to this convolutional neural network, there is a question which is very widely asked that if, let's say, I am providing you a input image which is having a size of 5 cross 5. And again, the default kernel image is available. Size is 3 cross 3. Kernel size is 3 cross 3. You are doing a stride by 1. And there is also a concept of what we called as padding. We will cover up in the upcoming part of today's class only. But for now, we will take this variable as 0 because we have not understood this concept. This is a very widely asked interview question in with the topic of the CNN, that given this criteria, having input image, kernel size, and the stride value, how much is the dimensions of output image? What is the output size? What is the output size? How will we able to get that? Now, one option could be you will do it manually, just like the way we have done above. We are checking We will take 5 cross 5 image, we will take 3 cross 3 kernel, we'll do manually each and every calculation and then check what is the output we are getting, what are the dimensions for that. That's something which will take a lot of time and interviewer won't wait that much amount of time. So there is a formula to evaluate this specific part, and you always have to remember this. The formula says whatever be the input size of the image you have, take it as it is, subtract that kernel size, whatever you have, plus 2 times if you have a padding available. Padding, I'll talk about what is this concept, divided by stride plus 1. Always remember this 1 is outside this division part. So whatever value you are getting from here, you just have to add plus 1 on top of this. For example, what I am saying is input size 5, kernel size 3, padding we are not applying, so 2 into 0. Stride value is 1 plus 1. So in this specific case, 5 minus 3, 2, divided by 1 is 2 only, plus 1. So the answer will be 3 over here. It means that if someone is asking you what is the output image, it will be 3 cross 3. Are you getting my point? Is this clear? How we will be able to get the shape of any specific output image? So this is the formula which you always have to remember. For example, if let's say I will say that the input image that we are having belongs to 10 cross 10. The kernel is again 3 cross 3. The stride is, let's say, I'm saying as 2. So can you just help me to understand what is the output of my image? What are the dimensions? Can you just let me know, everyone? Any other answer? Decimal number, do you think any specific image should have decimal value? Always remember, that is again a very important thing. When you will be working with image data, yes, so whenever you will be working with the image based data, it will always, convolutional will always work with discrete steps. Discrete means that it will always be a whole number, 0, 1, 2, 3, 4, and so on. And it will take, if you at any point of time getting a decimal number, it will take the lower value, or I would say floor value. So floor function will be applied with respect to whatever be the value you are using, plus 1. So what is the, I would say, formula we have? Input size minus what is the kernel size plus 2 into padding will be 0 divided by stride. 7 by 2 is 3.5. Apply the floor function on top of it. So it will become 3. I hope everyone knows what is the meaning of floor. Floor function usually tries to decrease the value with respect to whatever number you're getting. The lowest, closest value it will be able to give to you. So 3 plus 1 will be 4. So the output dimension will be 4 cross 4. Will that be clear to everyone? Shall we proceed ahead? So now in future, if anyone will ask from you that I will provide you the specific input image, kernel size, stride, and so on factors. So I hope that you will be easily able to answer to them that what is the output shape that we will be having. Now, one important thing, we have already by default taken the value of padding as 0. Let's try to understand that what is the meaning of padding and what will happen when we introduce this padding value as 1. What will happen when we introduce this padding value as 1? First of all, let's try to see and analyze what will happen in that case. Let's go back to our very first example where we have input shape 5 cross 5, kernel size 3 cross 3, and now stride value is also 1. If I'll ask you the padding is 1, can you just help me to understand that what is the output image dimensions? Can you just help me to understand what are the dimensions of output image? Yep, it will be equivalent to. So you can apply the formula uh, input shape minus kernel size plus 2 into padding. Now it is 1 divided by 1 plus 1. So 5 minus 3 plus 2 divided by 1. So this value will become 4 plus 1. So can I say everyone, as per our calculation, the output size will be 5 cross 5. So at any point of time, if you will be able to observe over here that as soon as you will introduce the padding as 1, this output image and the input image will be equal to each other. This is the impact. So in this case, as soon as you will introduce padding, it will make the input and output shape or dimensions exactly same. Now, what is the significance of this? If you will see previously, when the padding was 0, the output dimensions was 3 cross 3. Currently, we are getting the same output dimensions as the input dimensions, which is 5 cross 5. What is the impact for this? And what is the significance of the padding? Let's try to understand now pretty well. Let's suppose that you will be having a 5 cross 5 image. When I'm saying 5 cross 5, it must be 0, 1, 2, 3, 4. Or let me do one thing instead of writing on my own, which will take a lot of time. I will fetch one image and then maybe showcase you the concept of padding. Can you see? In this case, before padding, you will be having the input shape of 5 cross 5. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. And let's suppose these are the numbers we will be having. Don't get confused with the bigger quantities that till so far we have seen -1 and +1, how these numbers are coming up. We'll discuss this later on. But for now, try to get the concept clear that let's assume that this is the input shape we will be having. Now, what will happen, what the padding will do, as soon as you will say padding value as 1, so it will try to take one layer of zeros. This is what we call as zero padding, where it will apply in your input image the outer boundaries, all the values at 0. So in a way, this complete matrix will become now 7 cross 7. And usually on this specific part, now kernel will be applied to give you an output image of 5 cross 5, which you were getting above. So in a way, your original input size, original input image is also 5 cross 5, and your output image is also 5 cross 5. Is this clear? So padding means we are trying to add one extra layer, extra column, row value on top of the input image that we will be having, so that we will be able to retain the size of the original input and the output image same, which is 5 cross 5. Is this fine for everyone? These all we have seen is in a square matrix. You will always have the shape of the input image is in 5 cross 5, 3 cross 3, 7 cross 7, 10 cross 10, 28 cross 28, and so on. Priyansha, I'll come up with your question, with your answer as well. What is an output image? In output, what do we get? The probability or the output image? When we started our discussion, I have showcased you what you will get as an output. I hope you remember. This is the output. On top of this, you will apply the activation function, which will convert it into a probability. How it will convert? You will have a target images available as well. For the target images from 0 to 9, also we do have the pixel values available. It will try to compare your output with the pixel values of the target images that we will be having from 0 to 9. Now it will check that which is having a closer match of this output image feature map and the output image that we will be having target image value. Whichever is having a closer match will have a higher probability as comparable to other things. So anyhow, for now, we are covering up how the CNN will work, how the internal maths will work when we will apply filter, how we reach to the exact output of probability. I have not covered up till so far. So don't worry, we will cover up that portion. For now, just have your focus with respect to what I'm trying to convey with respect to how CNN will work. If that story is clear, then that's an upcoming story that how we will reach to a point of probabilities. So before moving ahead to the next layer, that how we're getting the probabilities, please try to have an understanding that how, first of all, this feature map will be generated. This is the output which will be given to us by CNN. So how we're getting this output, is this clear to everyone now? And the concept of padding as well. Is this clear to everyone before we will move ahead? Do you have any questions about whatever things we have covered up? There are few more terms which I will definitely have to explain before we will proceed ahead. But before that, if you have any questions, please ask, because once we will start the implementation, then if you will ask me these basic questions, then it doesn't make sense to me, right? Why padding is needed? This is the question. Now, anyone who can just let me know why padding is needed? I think just with the uh, use case which I have demonstrated you, you should be able to understand that why it is needed. At any point of time when your expectation is, so always remember, by default, usually when you apply the convolutional neural network, your if you will know, if you will not apply any padding, if there is no padding, just like the way we have done above, you will always get the input image dimensions more than the output image dimensions as per the metrics calculations that we have seen. But if, let's say, you are working on a project where you want that the output image should also have the same size with which I am starting my input image project, in which I am feeding the data set. So in that case, at any point of time, when you want that specific criteria to be done, you will apply one padding, and this will make sure that your input image dimensions and your output image dimensions both are same. When you apply 2 times padding, that is also possible. 2 times padding means you will apply 2 0 layers, right? In that case, your input image will most probably be smaller than the output image. So at any point of time, if you want my dimensions of the image should be bigger in the output as comparable to my input, in that case, you will apply further padding. But in a usual scenario, this thing we don't do. And this one size padding is also something which, if required only, then only we will do. We will always prefer to go with this specific criteria, because lower output image size means lower dimensions, lower space required to store that output. So this would be much preferable rather than going for higher padding values. At max, you will go with this specific criteria, where it might be the case that your output image that you will be having, you are further feeding that specific image into a new model to generate something new. In that case, you will always have to make sure that the images which you are using should be of same size. In that case, you will go with the padding. So far, so good. Can I assume? Just give me a second. Okay, perfect. What is the question? Padding means adding an extra layer in the input image of zeros. So whatever be the original input image we have, adding the extra layer of zeros on top of that, so that we will increase the dimensions or the metric size of our input image from, let's say, 5 cross 5 to 7 cross 7. As and when you will increase that, then the output image which you will be able to get will be of 5 cross 5. Why we are doing so? Because we want, at the end of the day, the output image dimension and the original input image dimension should be same. That's the meaning of padding. Clear? These zeros won't impact your original image. So if you will be able to understand, these are just the zero values. So no impact at all. It just increases the size of the matrix. That's it. How to reshape the input image? No need to do it manually. So whatever concepts I am discussing over here, right? I am discussing in a lot more detail. giving you a in-depth explanation of how the things are working. When you will see the implementation of all of these things today, you will be amazed that we are not doing anything. We are just calling our functions and everything is done. If I want, I can directly start with writing a code in today's session and create a convolutional neural network with you. No need to give you this kind of explanation as well. If my focus is just to make you guys uh, help you understand the code part, I will explain you one by one step line of the code, and everything will be okay for you as well in that case also. Here, I am explaining you the internals of each and everything. Please try to understand. Don't think that whatever she is explaining, we have to do it manually in our code. We are not doing anything manually from scratch. This deep learning has nowadays become so matured. We have lot many modules, functions already available with us. You just have to call pad. It will do the padding. You just have to say padding is equals to 1. It will do that. What it will do, you should know. There is a concept of max pooling. You have to do that. You will have to, apply that max pooling concept. It will automatically do your job. But how will it do? What are the internal things it will do? How the convolutional is happening? This is what, first of all, you have to understand. So whatever you are understanding over here, when you implement a code, you cannot say anything. You will just see the output. How this explanation of internal things helps us to stand from those do it by coding knowledge only. When you will go for the interviews, interviewers will ask you to these questions only, which I am explaining over here. If you won't able to answer, you won't get selected. Every interviewer will check your fundamentals and the internal knowledge. Writing a code nowadays it's not a difficult task, considering we have the platforms like GPT, LLM based tools like Perplexity. What is lagging? What is the gap? Is people don't know the maths behind anything. People just know how to implement a code. That too, they're copying it from GPT platform. They don't know what actually internally this code is doing. So if interviewer will ask you at any point of time, hey, you have applied the functions con 2D, what this function is doing internally, can you just help me to understand? You will be blank if you don't know how these things are working. That is where you will be able to send out. I hope it answers your question. Shall we move ahead, everyone? Perfect. Now, the next important concept is, as you can see that usually getting this kind of results, uh, where we will be having this feature map or the output shape might be a, you know, bigger space consuming task, right? And the input shape might also be of a very big size. It might be the case. In that case, we have a concept of something called as max pooling. So if, let's say, you have the image available with you, and you are saying that, for example, here it's 4x4 image I have. This is the input image that I will be having. Just give me a second. Whether we will do max pooling today. ठीक है, इसको भी कर लेते हैं. So what I was saying is, let's suppose that you will be having this specific image available with you. Now, you have applied a convolutional part, feature is being mapped, and you will be able to get finally this specific answer, right? Maybe you will be able to observe that this specific answer is quite bigger dimensional part. I don't want to take this much memory to consume. So in that case, you can apply 2 cross 2 max pool. What is the meaning of this? It will take 2 cross 2 internal metrics. And when you say max pool, it will take the maximum value out of this and return that specific answer. Then further, it will go next 2 cross 2 matrix, will take the maximum value. Then it will go further 2 cross 2 matrix, will take the maximum value. It will further go 2 cross 2 matrix, will take the maximum value. So in this way, we will be able to gain a final output as this specific matrix rather than the previous one. Now, why is this helpful? Any answer? Any guesses? Exactly. So first thing, that it will help me to reduce the computational cost, right? Now, instead of having a bigger dimensions, which I have to store, I am just using a smaller dimensional part. The second interesting thing is, I would say, that it really is helpful in terms of storing the essential features. So when I'm saying maximum value, it means that whatever be the important crucial features that we already have stored it, right? So this is also one of the possibility which you will see that in almost all the CNN based architectures researchers are doing in order to make their code more efficient. So if you will see from next day onwards, the 2 cross 2 max pool, don't get confused at what they are doing. Somehow they're trying to reduce the dimensions of the output image in such a way that whatever metrics they're specifying over there, they will take the maximum value from that. That's the whole idea. Is this clear to everyone? Essential features meaning most important features. Most important will always have a higher value, isn't it? Whatever features are highly significant. Padding is a concept. It's an optional step. When it is required, do that. When it is not required, you don't need to do. I told you, padding is usually not recommended. In general, in any use case, if you have the criteria that the I just want input and output dimensions exactly same, then only go with padding value as 1. Otherwise, don't do that because that will somehow computationally expensive task. But if let's say in your research it's required, we do have a concept. So I have explained you the concept of padding. I didn't say at any point of time that you have to do this thing. I hope it makes a significant difference in my lines. Is this clear? Shall we move further? Yes. Apart from max pool, we do have different pooling concepts as well. For example, you might, after this session will get over, I will highly recommend everyone to explore on your own the different CNN-based architectures. You will see that in few of the documentations, it's mentioned as average pool. What is the meaning of average pool? In that case, they might take the average value of the numbers. When you are saying average pool, ये क्या हो रहा है? When you say average pool, it means 12 plus 20 plus 8 plus 12 divided by 4. So whatever value is coming up will become the very first value over here. Then it will take the next average value, next average value, next average value. So if you want to inculcate all the features rather than introducing a high value, maximum value, then average pool will come into picture. So similarly, we have different ways to do the pooling part, but usually again, multiple times, max pooling is the highly frequently used way to get that reduction of the computational cost and to get that essential features. Will that be okay? So now the concept of how feature map will be created via input image and filter, meaning of stride, how we will be able to get the output image size by applying a formula of input image minus kernel plus 2 into padding divided by stride plus 1. How the concept of max pooling will work, what actually it is giving to us via max pooling. If A need will come where I have to make sure that the size of the input image and the output image should be same. Then how the padding concept will come into picture and will help me to do that. Can I assume everything is clear to everyone? Before finally we will jump towards the upcoming stage. Tell me if it is clear or if it is not clear. Yes, max pool we will always use in the output image to extract the important features at the end of the day. Again, all these concepts, padding, max pooling, try to understand the concepts and don't take these as the essential steps that we have to do. So in every architecture, in few architectures people are doing it, in few of them they're not doing it. It all depends on what kind of project we are working on, how sensitive our data is, whether we want to extract the most important features or all the features. Accordingly we will take our decisions. For now, as a beginner, you should know all these concepts pretty well, and if the need will come, you should know how can I apply them. That's the whole idea. I already have explained this question, why there is a need to make sure input and output image size is same. When you will be having a very bigger complex architectures, in that case, it might be the case you have the input image available. From this input image, you have applied the internal architecture, you got some output image. And let's suppose this output image might be the input of next specific architecture. You are working with a bigger architecture. So in that case, when next output image will become the input of next specific layer, you have to make sure the size will remain the same in order to retain the complexity. That's the whole idea. That is where it might be necessary. This is one of the use case. Again, I'm explaining. There can be multiple things. When you will move further and check out the research papers, you will get to know more details about the same. Is this fine? Is this fine? Shall we move ahead if everything is still so far clear to everyone? Now, the question that was asked initially to me, that we have talked about soft maths, we have seen probability will be there. Now you're talking about feature map, we will be able to get matrices. Then how softmax will be able to give the probability? That's the second question which I am answering now. Okay? Considering that till so far what we have covered up is clear to everyone. So let's assume that we got the feature map of, let's say, 9. And this is the feature map that we got. Now we know how we are getting this. Yes or no? Now we know how we are getting this. Yes or no? Yes? So what will happen? There is a concept of what we called as flattening. Flatten function you have to use in general in deep learning to do this step. What will happen? This matrix shape that we will be having in the output, it will automatically get converted into a neural network shape. Now, neural network, we know how it works, how it will be able to give the input layer, hidden layer, output layer. So now we are working on that part. So what will happen is, whatever be the output you are getting, minus 0.11, 1, minus 0.11, minus 0.55, 0.11, minus 0.33. In this manner, till the very end, we will be having minus 0.33. When you are saying flatten, it will try to convert this matrix into a one-dimensional data where all of these values available in the matrix. Row wise, it will be able to write it down in the input layer as an input feature. Okay? Now the same process. This is what we will be having is the input to our neural network. Now you can see how the previous concepts that we have covered up in our previous discussions of the classes, neural network, we have created in the last class the complete neural network architecture from scratch as well. At the end of the day, it will be used over here as well. We have applied a CNN architecture. Now, once we will be able to get that output value, we will be able to do the flattening and we'll create a neural network over here as well. But in this case, our input features is not the values which we will type manually. It will be given to us via feature map. How this will be created, now we already know. Now we will try to create the hidden layer. Maybe let's say you are creating two hidden layers. One is of 128 neurons. Another one is of 64 neurons, that just like the way we have done yesterday. Or maybe day before yesterday. I don't remember which day we have met last, but this is what we will be able to gain. And finally, in this specific layer, or if you want, you can create a single layer as well. It all depends on you. If as of now, if you want to create one hidden layer or two hidden layer, let's make it more easy. Let's take only one hidden layer of 128 neurons. And let's say we will be having the output layer now. So this is input, this is hidden, and this one is output. Now tell me in the output layer, how many number of neurons we want? 10, very good. Not one. We have 10 classes. We will apply the activation function as softmax over here. In the above case, we will apply the activation function as ReLU to make our computation bit easier. And now, once the weights will be assigned, again, feed forward propagation will happen. It will try to move ahead, will try to provide the probability of all the values from 0 to 9. It will try to check the final value. For example, let's say this is predicting the probability of 9 image as maybe 0.90, 90% is the probability. So in that case, it will try to map with the original image. What is the actual target value? What is the target value? Target is also 9. And our model is also predicting that the probability of 9 is high. Then it is good. If let's say our model is predicting the output as the image of 8, but the target of this specific output is 9, there is a mismatch, there is an error. Which specific loss function we will use over here? In a softmax, which specific loss function we will use? Refer our previous discussions and let me know. Very good. It will be categorical cross entropy. So we will use that. It will try to figure out the difference between the actual and the target. If the difference is huge, it will go back, will do the back propagation, again update the weights, and the training will keep on going till it reaches to a global minima where it will be able to give us the result in an accurate manner. Getting my point? Now the picture is clear that how at the end of the day, from this feature map, we are reaching to the probability part. If it is clear, if you don't have any question, I really want to implement the same thing in today's class itself, because you just now have understood the concept. It will be good if you will do the implementation as well, side by side. The updation is taken place in flattened matrix. Not in matrix. Not in matrix. This portion is the first step. This is done where you have applied a CNN architecture. This neural network architecture is a second step. Now, the second step doesn't know how I got that first output feature map. Once you flatten this value, now everything we are doing in this neural network architecture, there is no interconnection to this output feature map now. What we are doing a update, when I'm saying back propagation, we are updating the weights and biases. I hope you all remember my previous discussion session. The concept that we have covered up in neural network, same concepts you have to apply over here. Forget about now feature map. Now you have a normal neural network. So whatever be the study you have done till so far with respect to neural network, how it works, how the feed forward propagation works, backward propagation works, updating of weights works, optimizers work, loss function work, complete case study will be same. No difference. So I am expecting that you are pro in this. What you don't know was this. Today I have explained you this. That's the whole idea. Can I expect? Because in the last class, we already had done the implementation of neural network as well. And before that, we have spent, I think, 2-3 sessions just to understand about neural network. So what we were not aware about is the CNN. So today you have not learned about neural network. Today, the new thing which you have learned is CNN, how it works, what's the internal maths, how it will be able to generate feature map, concept of padding, concept of max pooling, all those things. In interviews, can they ask mathematical implementation? No. They won't ask mathematical implementation. They will ask the mathematical concepts. And then in terms of implementation, the way I will do now, right now, like the way only you have to do. No one will do the implementation from scratch in industry. Why will people do the implementation from scratch? It's just a waste of time, waste of resources. People want result to be delivered in a faster manner. So, but at the same time, they're expecting you to know the internals behind it. If you don't know, that is where a big trouble is. Nowadays, if you will see the people who are working in the companies as well, if you will ask from them what is the internal behind this specific thing which you're writing a code, they will say that, hey, it's just a black box. Don't care about this. But when those people go for the interviews, they won't be able to crack it because they don't know the internals behind the things. So firstly, we have a CNN model, finally makes a feature matrix. It goes to neural network where feed forward propagation happen in layers. Then output layers shows the probability as an output. Exactly right. It is what we have covered up till so far in our today's discussion. A summary of what we have covered up. Is this fine? What is the maths behind flatten? No maths, it's just an input value to our layer. So what features we will be able to extract? On those features only we have to give the probability, na? That whether the specific image belongs to which specific part. So what we want is that all these, we will apply dense layer meaning that all these input values which we are getting as an output from CNN, where CNN will be able to capture this one as well. We are passing as an input. Randomly weights will be initialized. And hidden layer will be able to see that which specific input value is quite important. We'll be able to extract the important values from there and will be able to give the results. So everything related to what we have covered up in terms of mathematical part is the intuition behind how it will be able to give us the final probability. By CNN only, we get 9 as a target value. Yes, we will get 9 as a target value. So you will see what will happen when you are training your model, when you are saying, I'm training my model. At the time of training, what will happen? You are passing one input image which belongs to 9, something like this. And you have a mapping of this to 9, that this image belongs to 9. This is the target value. Now you have applied a deep learning model. At the time of training, this model is saying that this image belongs to target value as 8. There is a mismatch. Error will be very high. Training will happen again. So When I'm saying reaching to this step to this target value, this is composed of two steps. One step is to converting this image to pixels, having the CNN architecture done. After that, flattening layer, getting the value in terms of probabilities by applying activation function as softmax. So this is the entire process which I have explained you. So when I'm saying my training is done meaning we reach to a point where our error is minimum and our accuracy is maximum. Means we are reaching to a point where my model is also saying that this belongs to an image of 9. So with respect to every image, we have a mapped value available already, a target value available already. Yes or no? Let's try to do the implementation as well. Now, just open the same file which we have discussed in our last class. We will do the implementation from scratch, and then maybe we will wrap up our today's class because I also have a meeting. This is the link. Just let me know whether we can start or not our implementation of whatever we have covered up. So first step is again importing all the required libraries. I'm copying it from above. Apart from this, today we need to import further models and the layers as well. So first of all, what kind of layers we will have to import? Convolutional 2D layer to do that convolutional part that we have discussed today. Max pooling 2D layer to do the max pooling task if we want to do. Flattening layer to do the flattening task. So in this way, you have to just call the functions and it will do your task. We will not do anything from scratch. Already we have functions available. We'll just call them. Now we need to load the data. It's an open source data of MNIST. So we can take the data from TensorFlow dot Keras dot datasets. Here you can import the data of MNIST. So step one is to import all the required libraries. Step two is to load the data. So what we will do now is we will try to load the data entirely. So how can we load it? We will try to split our data into two components. Training set, we will split into X train and Y train. And then we have a test set, X underscore test and Y underscore test. And we will call the function MNIST dot load underscore data, which will help us to load the entire data in one go. Now, what we will do is we will try to normalize the pixel values available in our data set of X train and X test. So X train is equals to, here we are trying to say X train dot reshape. We are passing -1, 28, 28, 1. Now I will talk about this, what all these values indicate, but for now just take it as it is, and I'm dividing it by 255.0. Similarly, do the same step for X test, where you will say X test dot reshape -1, 28, 28, 1 divided by 255.0. Just do this much. And then we will do the step number 3, which is to build the CNN model. Before that, let me explain you what we have done in normalizing step. Just let me know once you have written till this much, and then maybe we can move ahead. You can maybe open in your screen this specific file as well, and you can directly copy paste as well if you want. Just confirm me once you're ready to understand the normalization part. Okay. So I'm copying this code. Let's try to spend some more time because this will be very helpful for you if you understand it clearly that how this normalization usually happens for the images. First of all, whenever we are working with images, image-based data, you will see there are two forms of images we do have. One is what we called as grayscale image. Another one is what we called as RGB-based image. I hope you all know. Black and white kind of image is what we called as grayscale image. Colored image is what RGB image. When we are saying grayscale, it means that it just have only one channel. RGB by the name itself, it contains 3 channels. Okay? So when you are working with MNIST data, the input size is 28, 28. And this one indicates that this is a grayscale image. This is a grayscale image. If it's a RGB image, it will be mentioned as 3. Is this clear to everyone? So if I'll just showcase you with pictorial representation, RGB image. This is a kind of a 3 channels which I'm talking about. Let me save this image for your better clarity. Let me take the example of grayscale image as well. This is a kind of a black and white image we do have. Uh, I think this looks better for clarity. Getting my point, everyone, after looking into this picture? So when I'm saying 3 channels, it means red, green, blue. So 3 matrices will be there. So it will be a more load to our system to store the RGB image. When you are saying grayscale, It's just a one channel, one matrix we will be having. Are you getting my point? That is why usually when you are working in the companies also, and let's say you are getting the RGB image as a original image, original data, you will see in few of the cases, people are in a data pre-processing step, converting the RGB image to grayscale image. This is a very, I would say, most common practice, so that it will be very easy for the system to do the computational part. Because when we take directly RGB images, we will be having three separate matrices, and our data will be computationally very much expensive. In that specific part, computation will be very expensive. It will first have to do for R wala part, then G wala part, then B wala part. Now, is this clear? What is the meaning of 28, 28, 1? 28, 28 is the size of the image. 1 indicates a one channel, means grayscale image. Can I get the confirmation? Is this clear or not? Any doubt over here? What I have not explained, I'll explain. Is this last three numbers are clear or not? 255, what is 255? What is -1? I will convey. This is where I am here. Wait for a while. What I have explained, is that clear? What these last three values are indicating, everyone? Before we will move ahead to discuss the other two values which are pending. I'll discuss, don't worry. That's why I have copied it. Now let's talk about this -1. In both the cases, what does that indicate? It indicates the number of training samples. So usually in MNIST data, I think we have 60,000. Let me recheck how many we have. Hmm. 60,000 are the samples we have for training set, and 10,000 we have for the testing set. If let's say you don't know the count of the number of training samples or the testing samples, in that case, you just have to mention -1. -1 automatically takes whatever count we have for testing set and the training set. So what we are doing over here, we are saying for all the 60,000 images, convert them into a proper structured manner of 28, 28, 1. For all the 10,000 images in the testing set, convert them into 28, 28, 1. That's why we're using reshape function. After that, we are dividing by 255. 255 is the highest pixel value. So when we are doing a normalization, the values are usually lie from 0 to 255. 0 is the minimum value in the pixel, 255 is the highest value. So you can see over here, we can see 255, 255, 255, 255, right? 255. The maximum peak value we have in the pixel part is 255. So we are dividing it by 255 to normalize it well. That's the whole idea. This is how we will be able to get the training and testing set. Is this clear to everyone now? -1 by default will take the total count of number of samples. So instead of writing -1, if you write 60,000 also, that will work fine. If you don't know how much is the count, you can mention -1. By default, your model will be able to understand. This is the interpretation of your model. -1 indicates just you will do the count of training sample and take all of them. That's the whole idea. Yes. You can use -1 when you don't know. You can use in other cases as well. Usually I prefer to use -1 only. Even though if I already aware that how much is the total count, mentioning huge number of values or the data points will be a most trickier part. If you just miss a single zero also, it will not do for all the training samples you have. Better practice is to write -1 in that case. Make sense? Shall we move ahead now? Clear? Shall we build the CNN model? Are you ready? Perfect. Now let's build it. Model is equal to, again, we are applying a sequential layer. I hope everyone knows still so far what is the meaning of sequential. Yes or no? Stack of layers we need to create, right? First of all, we will do the convolutional part. We will apply conv 2D. Now, I'm mentioning 32, comma 3, comma 3 activation as relu input underscore shape equal to, what is the shape of my data? 28, comma 28, comma 1. Anyone can guess what is this 32 indicates? In this specific entire part, I think everything is clear. Kernel size is 3 cross 3. Activation function we're using as ReLU. Input shape we all know, just now we have covered up. Anyone who can just let me know what is this 32 indicates? Exactly. Only one student have given the right answer. Here, 32 is not neurons. In convolutional neural network, we are not talking about neurons. 32 is the number of filters which we are using, each of dimension 3 cross 3, because we are having 60,000 images in the training set. If we will apply a single filter, again, it will take a lot of time to grab all the input images that we will be having. So we are applying 32 filters, okay, to do our task simultaneously. After that, once we will be able to get an output, we will apply a max pooling layer. Because it's a computationally heavy task, I want it to reduce the dimensions. With the pool size, you can apply, let's say 2 comma 2 for now. That's what we have covered up in our discussion as well. So what it will do, it will take in the output value 2 cross 2 matrix, will take the maximum values only. It won't store the entire output matrix for now. Is this clear? Give me the confirmation. What's the third step? We are ready with the output. In the feature map, we have done the max pooling of 2 cross 2. We got the output. What's next we should do? What's the next step? What's the next step? Flattening. Now we are moving towards the, so step number 2 internally in the convolutional neural network to create a neural network architecture. Internal step, 2 steps we have covered up. Internally, 2 steps. One step, CNN. Second step, neural network. So it will try to do a flattening. After that, what's next? Flattening is done. So simple. We have to call the function. Yes, you just have to do conv 2D. Just have to apply here what is the count of the filters or kernels you want, how much is the dimensions, what is the activation function at the end of the day you want, how much is the input shape which you're passing as an image. It will do whatever operations we have covered up in our discussion, same operations. Max pooling 2D just have to apply as a function. It will do what we have covered up. Flatten, just apply a function. It will do what we have covered up. What's next? Input shape ready हो गया हमारे पास में in a neural network. To create a dense layer, hidden layer, dense, number of neurons, let's say 128. Activation function, यहाँ पे भी we can use ReLU. What's next? Dense output layer, 10. Activation function, softmax. तो न्यूरल नेटवर्क में ये हमारे पास आ गया इनपुट लेयर. Then we have the hidden layer. Then we have the output layer. Are we ready with the model? Are we ready? What's the next step? Step number 3, compile. Shall we move to the compilation part? Few things we have to change in the compile part. We will have to change the loss function. In a categorical part, it will be sparse categorical cross entropy is the full name, which you have to write. Metrics, we can change or we can take it as it is. Accuracy is fine. Here, because we need to train our model, so step number 4 is model training, where you have to apply model.fit, mention your training set that you have, xtrain, ytrain, how many times you want to do training, epochs, let's say I am mentioning over here 5. And then what is your validation data to check whether your work is perfectly fine or not, our testing set, x underscore test and y underscore test. Let me do one thing. First of all, you can do in one code block as well, but let me take it step by step. So I have written the entire code. I will try to execute it code step by step in every code block, each and every step, so that you will get to know what is happening in every step. If you want, you can run it in one go. Usually I run it in one go, but because I'm explaining you the concept today, I will run it one by one. So it will import the libraries and load the data. We'll wait for some time. Some issue is coming up. Let's see. Oh, spelling mistake. Conv2D. Spelling mistake. Where we have done a mistake. TensorFlow. Done. Dataset is loaded. Step number 2 and 1 is done. 1, 2 done. If I'll just try to showcase you, print y underscore train. Can you see the mapping now, everyone, which I have told you? Already we have a mapping of numbers in the training and the testing set. Can you see everyone? Actual target values. So all these are the actual target values. Can everyone see this? That's why I have done it in one by one step to showcase you this thing. So target is not the image, target is the values from 0 to 9. So if you will pass the image of 9, it will give a number 9, that it belongs to 9 image. That's the whole point. Confirm to me, is this okay? Shall we move ahead to the third step? Building a skin model. Run this part. Let's see if we get any error or not. Done. Now compiling and fitting might take some time. Let's do it. Training is started. I have just mentioned 5. At your home, just try to do more epochs to get a better accuracy. It will take some time, and after that, you will be able to see in every iteration, we are getting the training accuracy and loss and the validation or testing accuracy and loss. In every iteration, your accuracy should be increasing, ideally, and your loss should be decreasing. Done? Now, final thing is to call the summary. I think this you can do at your home. Today, take it as a task. And in the next session, I will ask from you that how these parameters are coming up. And you just have to explain to me that what is the answer why we are getting this kind of answer over here. So this is a basic part in which we have covered up how the training will be done. In the upcoming part, we will discuss that how can we save the model? How can we make the model predictions? I have not showcased you till so far. We have get our model ready, but now we have to see that if I will pass the input image in MNIST data, will it be able to give me the exact answer or not? So these two portions in the project we will cover up in the upcoming part. But till so far is the maths behind this CNN architecture and how we are doing the implementation of this is clear to everyone. Any doubt till so far? This is your task for today. We will start from this specific portion itself in our next session. Task is to determine the reasons behind the param values in the below table. So you have to give me the explanation in the next class. Also, in this specific part, try to do on your own the predictions. See which specific method will be able to give me the predictions now. How can I get that predictions? On your own, do it. Also, I will discuss it in the upcoming class, but for your research person, you can do that. It's quite easier step, not a difficult one. Difficult part, we already have done it today.